Hello everyone. This is week 13, lecture number 2, Laplace transform. So in previous lecture we studied Laplace transform, that how we can find Laplace transform. We started by simply taking the u of t function and then apply this formula and find out the Laplace transform, which was 1 by s, and then we did a few other example. For t we find out the Laplace transform 1 by s square. Then we find out Laplace transform for cos omega t, which was s by s square plus omega square. Okay. Then I gave you one example, so that you needed to find out Laplace transform of sine tan t. I hope so you already find that out and you got the concept. Then we studied properties of Laplace transform. So the properties which we derived and proved was time scaling, and then we proved the frequency shift property, and then we proved the time shift property. Okay. Now, previously I told you that in next lecture we're gonna study further about Laplace transform and inverse Laplace transform. Okay. So in this lecture we are going to first study the initial value theorem, okay, and the final value theorem, and then we're going to study a little bit about the inverse Laplace transform. Okay. So what is initial value theory? As the name suggests, that we need to find out the initial response. Obviously we are studying circuit analysis, so we are interested in initial response of circuit. That is, when at the start, when t equal to 0, what will be the response of our circuit. Okay. So if you know the overall function of your say of your circuit, say that is f of t, okay, and you need to find out the initial value, then what you do is you simply put the limit t approaches to 0. Okay, and you find out this limit, evaluate this limit, and you get the initial value for this function. Okay, you easily find out the initial response of your circuit. Okay. Now, what will happen if instead of time domain function you are given the Laplace transform function? Okay, that is you are given say f of s. Okay. Then how you gonna find the initial value for this f of t? Okay, you are given this function, you need to find out initial value of this function. Okay, so with the help of this initial value theorem, you can easily find out the response of this thing, okay, this function, using this thing, and this will be equal to s f of s. Okay, and you take limit t approaches to infinity. Okay, see, in frequency domain you take the limit okay, sorry, this is not t. Okay, this is s approaches to infinity. Your limit for s would be infinity and your limit for t is 0. Okay, you find this response, this will be same as this response. That's why I put equal over here, and this is called the initial value theorem. Okay, we can prove this theorem, okay, by simply taking solving few integrals. Okay, so let's say proof of initial value theorem. Let's prove it. Okay. So to prove this initial value theorem, we're going to need this this function. We need to integrate this 0 to infinity, and derivative, I'll show f dot means derivative of f. Okay, e raised to a power minus st times dt. Okay, I just need to evaluate this derivative. Okay, so we can say that this is equal to 0 to infinity, and this is time derivative of f of t. Okay, so we can say that this is df of t by dt times e raised to a power minus st dt. Just solve this integral, and you will get the idea that how this thing equal to this thing. When s approaches to infinity, f of s gives you the initial value for the function f of t. This is same as when t approaches to 0, you put this limit for f of t. Okay, so let's say we solve this integral. So this is two functions, right? So first we take e minus st as a first function. So e minus st, and we take integral of 0 to infinity, okay, d by dt f of t times dt, okay, and minus, okay, 0 to t, and we can say that this will be derivative of this first function. This will be minus s t, sorry, minus s e raised to the power minus st times integral of d by dt f of t times dt. Okay, so this is simple, the integral. Okay, because these two functions are multiplied, so I applied this formula. So you can write it this way: e power minus st, okay, times, we can cancel this d of t with d of t. This become df of t, and df of t gives you integral f of t, right? And this integral will be from 0 to infinity. Okay, and plus we can take this s out, so this will be minus, so this will be plus s, okay, and this will become 0 to infinity. Okay, this is 0 to infinity, and f of t times e power minus st dt. Okay, you know how I get this f of t? By cancelling this thing with this thing. Integral of f of t is f of t, okay, and e power minus st dt. Now look closely, what is this? What is this? This is f of s, right? So we can write it this way, that we can evaluate this values over here. If you put infinity over here, this going to 0. If you put 0 over here, this become 1, and this become f of 0. So we can straight away write down that this is f of 0, okay, and but f of 0, this will be minus, remember? Okay, now this will be plus s f of s, right? This thing is nothing but f of s, okay. If you remember from our first from the start, I told you that this thing is nothing but integral of 0 to infinity f of t e raised to the power minus st dt. This is equal to f of s, so I just put this value f of s, okay. Now this is what you get at the end of solving this integral, okay. Now this was equal to what? This was nothing but from 0 to infinity we evaluated this function f dot of t e raised to the power minus st times dt. Now let's say this is your final answer, okay. Now we're gonna play with this thing a little bit, okay. So moving on to next page, I'll write this function again, that finally we got this thing 0 to infinity f dot of t. F dot means derivative of f of t e raised to the power minus st times dt, and this was equal to s f of s minus f of 0. Remember, I write this thing capital F and this thing small f, okay. So just remember that. Now let's say we apply limit to this total equation, that is s approaches to infinity over here, and limit s approaches to infinity over here, okay. I apply limit s approaches to infinity. What will happen to this then when s approaches to infinity? Okay, here is a term e raised to the power minus s, so this will be minus infinity. 1 by infinity is 0. Okay, so this term will be straight away 0. Okay, and here I'm not applying limit yet. So this is limit s approaches to infinity, s f of s minus f of 0. Okay, I can rearrange this equation as f of 0 is equal to limit s approaches to infinity, s f of s, and this is small f, so it means here the t value is 0. So it means that I can write it this way as well, that when t approaches to 0, f of t is actually equal to limit s approaches to infinity, s f of s. You see what we got in at the end? The same which we claim at the earliest, that when t approaches to 0, limit, when you put this limit for f of t, this is same as limit s approaches to infinity when you are in s domain and s f of s. Okay, so in frequency domain, in s domain, when you have a Laplace transfer function f of s, you can easily find out the initial value by applying this theorem, and this theorem is called initial value theorem, and here is the proof. Okay, so this is the end result we got for our initial value theorem. So this is the way to proceed. Okay, you can prove any theorem. Proving a theorem means that you already know the answer, that finally what you need to get. Okay, so you can perform any multiplication or division or integration, whatever you want to do. At the end you need to find out that value. That's what we did. Okay, so I think initial value theorem was easy. Now we are sometime interested in final value of our circuit, that what will be its final value. So that's final value. If you have the transfer function of that particular circuit, you can easily find out the final value, our final response by using this final value theorem. Okay, this is your final value theorem. So final value theorem states that limit when t approaches to infinity f of t. Okay, so what will happen in frequency domain? In frequency domain, your limit will be applied on s. So s will approach to 0, s f of s. Okay, this is your final value theorem. Okay, let's prove it, and then we're gonna proceed further. Okay, so let's say we can prove it by simply using the previous function. Okay, from 0 to infinity, derivative of f of t e raised to the power minus st dt. Okay, so this is equal to s f of s minus f of 0. Okay, this already we proved this, that this is equal to this thing, right? We already know this thing. We just prove that this is equal to this thing. Okay, now you just simply need to apply the limits. Okay, now you don't need to do further processing of this thing. Okay, we already know that this thing is equal to this thing. Okay, now we apply limit. Let's say limit s approaches to 0. Before we apply limit s approaches to infinity, right? Now we apply limit s approaches to 0. Okay, so this will be f of t, but f of t dot, okay, e power minus st dt, and here as well you apply the limit s approaches to 0 and s f of s minus f of 0. Again, one f is capital and one is small, so you should know what this denote and what this denote. Okay. So what we did, that we simply need to solve this equation. Now this thing is nothing but how you're going to evaluate this thing. It should be simple. When you apply this limit is equal to 0, it will apply only to this term, right? This term has nothing to do with this. Okay, so when s equal to 0, you put it over here, so this will become 1. This term will goes to 1. Okay, so this become 1. What you get at the end is 0 to infinity. Okay, d f of t by dt times dt to the left side of your equation. Okay, and I'm not changing this value, just simplifying that this limit will apply only to the s terms. Okay, so this is s, f of s only, and minus f of 0. F of 0 has nothing to do with s. They're the same way as here. So this and this we can cancel it out. You will get integral of d f of t, which will give you f of t. So when you apply the integral and apply the limit, you will get this f of infinity, okay, minus f of 0. Okay, what we did, that this is d f of t. So integral of d f of t is f of t. Okay, when you put this limit, so I put the upper limit is f of infinity minus f of 0. Okay, so this is equal to limit s approaches to 0. Okay, s approaches to 0, s minus f of 0. This is the final answer we are getting, right? So here this is minus f of 0, and here it is minus f of 0, so it's cancel out. And here this is f of infinity. Okay, I'll write it. I will write it. Okay, so this is what we get. F of infinity is equal to limit s approaches to 0, s f of s. This is what we finally get from this equation. Okay, now this is what? This is time domain. This is s domain. So we can say that, let's say, limit t approaches to infinity. We can write this function this way, right? F of t is equal to limit s approaches to 0, s f of s, right? And what is this? That in time domain, when time approaches to infinity, we are interested in system response at this time. Okay, but we don't have f of t, we have f of s. So what we do for f of s, we multiply with s, and s approaches to 0. That will be our limit. Okay, so this is called final value theorem. It will help us without taking the Laplace transform into time domain. Okay, taking this f of s to time domain and then applying this limit, you can simply easily find out the final value of this f of t by evaluating this limit. Okay, and this is exactly equal to this thing because we just prove that this is true. Okay, so this was our initial value theorem and our final value theorem. Okay, and now we can solve one example using this initial value theorem and final value theorem. For example, you are given say a function, a transfer function. Let's say this is f of s is equal to 10s plus 1 divided by s into s square plus 2s plus 2. And somebody asks you to find the initial value and final value of f of t. Okay, but you are given what the transfer function. Here we don't no idea what is f of t because we never learned how to transform this transfer function to time domain function. Okay, so what we studied that initial value can be found out from this value as well. We simply need to multiply this f of s with s and then apply the limit s approaches to infinity for initial value. Okay, so applying initial value theorem, okay, we can say that limit s approaches to infinity f of s. Okay, so here we multiply s over here as well, and here limit s approaches to infinity 10 s into s plus 1 divided by s into s square plus 2s plus 2. You just need to evaluate this limit. Okay, so we can cancel this s with this s and then apply the limits. So whatever you do, this will always end up infinity. 1 by infinity. Okay, because this numerator has a lesser degree compared to the denominator. Okay, so this is 1 by infinity equal to 0. So initial value is 0. Okay, according to initial value theorem. Okay, what will be final value? So we're going to use final value theorem. Okay, final value theorem. Okay, call this IVT and FVT. Okay, so according to final value theorem, you just need to apply this limit. Limit is equal to 0 and 10s into s plus 1 over s into s square plus 2s plus 2. Okay, s is cancel. Put s 0 everywhere. So s equal to 0. Here you get only 10. S 0, so here you get 2. So you finally get 10 by 2 equal to 5. This is your final value. See how simple it is. But if you are not using this initial value theorem and final value theorem, you will need to go back to time domain, then apply the initial condition when t equal to 0, and the final condition t approaches to infinity, and then you will apply this limit in time domain. Okay, but initial value theorem and final value theorem gives you this benefit that instead of going back to time domain, you can get your desired result by staying in S domain. Okay, so this is the beauty of this Laplace transform. Okay, it helps you everywhere. And the other thing is that applying limits to exponential function or say cos function, cosine functions, okay, a little bit difficult compared to this simple algebraic equations. Okay, the same way if there is some function which is undefined by undefined, this infinity over infinity, you need to simplify them. So simplification of cos function, cosine functions and exponential function are quite difficult compared to the algebraic function. Here you just need to apply L'Hopital rule, and the degrees of numerator and denominator goes on decreasing. At the end you get a constant value. Okay, so it greatly help you in solving such kind of problems. Okay, now moving forward to the inverse Laplace transform. So for inverse Laplace transform, you need to understand the Laplace transform first. As I told you before that you will not understand the inverse Laplace transform until and unless you understand the Laplace transform. Okay, so I hope so from previous lecture you understand already that how Laplace transform can be find out. Okay, and I told you that when you do some practice you will look into the function and you will easily say that okay, this is the transfer function, so this is the function, so this will be its transfer function, or say S domain. Okay, Laplace transform. Okay, now what will happen? Before in previous lecture we were given these things, okay, and we find these things. Okay, what if I give you this thing and you find this thing? Okay, so let me write it that before you were given f of t and what you find is f of s. Okay, you are given a time domain function and you find out the s domain function. Okay, now if you are given s domain function and I ask you to find the time domain function. Okay, So how this operation work? We just simply take Laplace of this thing. Okay, Laplace of this f of t gives you this thing. Okay, then reverse should also be true. So we can say inverse Laplace of f of s should give you f of t. Okay, so this is quite simple and complicated at the same time. Okay, complicated in the sense that you cannot transform directly f of s into f of t. You just need to split it into different components. I'll show you how you will split those components. Okay, for that splitting you must remember the concept of partial fraction. If you already forgot the concept of partial fraction, this lecture will be useless for you, so please just go back and study what is partial fraction. Okay, and there are two types of fractions. One is proper fraction and one is improper partial fraction. Okay, so you just need to understand this concept of partial fraction. Okay, so I'll just go and revise a little bit that how this transfer this work, but you will study it in detail by yourself. Okay, so it means that if you are given a function, say this one, say p x plus q over x minus a into x minus b. I know most of you remember how you find the partial fraction of this thing. Partial fraction means that this is equal to a by x minus a plus b by x minus b. Okay, this thing is equal to this thing. You just need to find out the values of a and b. How you're going to find these values, it's up to you. Okay, so I follow simple rule that I first multiply this whole equation with x minus a, then find out the value of a, then I multiply this whole equation with x minus b and find the value of b. Okay, how? Look, when you apply this whole equation by x minus a, this is what you're gonna get. Okay, this will be v of x plus q, okay, divided by x minus b is equal to a plus b into x minus a divided by x minus b. Okay, and in this I put x equal to a. Okay, now put everywhere where there is a x, put x over there. Okay, a over there. Okay, so this become a. Okay, I'll go to the next page. But so I can say that this will be p a plus q. P and q are two constants. Okay, I just put it over here. Okay, this will be a minus b. So a minus b, say a is 2, this is 3, so this will be minus 1 is equal to a. And when you put x equal to a, this will be a minus a, so the next term will be 0. Okay, so a is equal to this thing. P is a constant, a is a constant, q is a constant, a is a constant, b is a constant, so you get the value of a. The same way, for value of b, you just simply put multiply this whole equation with x minus b. Okay, so this is what you get at the end, that is if p of x plus q divided by x minus a, okay, is equal to a into x minus b divided by x minus a, okay, or plus b. Okay, because x minus b and x minus b cancel out. So this is what you get at the end. Now evaluate this at x equal to b. Okay, when you put x equal to b, this term goes straight away to 0. When you put b equal to x equal to b, this will be b and this will be b. So this is again, now previously it was a minus b, now this is b minus a. This is a constant, b is a constant, q is a constant, b is a constant, a is a constant. So you can easily find out b. So b is equal to what? pb plus q divided by b minus a. Okay, so that's how you find the value of a and b. Okay, so you find the values of a and b. Okay, and say we put some real values over here and then we find out, and then you will see that how we can find the inverse Laplace. Okay, so this was just a partial fraction. So let's say we take simple example. Say we have a transfer function s into s plus 1 divided by s don't take this example. Say we are given s by s plus 1 into s plus 2. Okay, this is your f of s. Okay, and what you need to find out is f of t. Okay, what will be f of t? F of t we need to find out. Okay, so for f of t we will need to use inverse Laplace, but before that we need to find out the partial fraction, and in minutes you will find out that why I need partial fraction. Okay, I just need to split this thing because I don't know what is this equal to. Okay, so I'll transform this equation into something which I'll know that if I take inverse Laplace of this thing, I'll transform this into something which will be Laplace transform of something. Okay, so I can go back to the original function. Okay, you will see in a few seconds. Okay, so we can say that this is s by s plus 1 into s plus 2, okay, is equal to a by s plus 1 plus b by s plus 2. Okay, this is our first step. You can divide your steps, say step 1, step 2, step 3, and so on. Now we need to find values of a and b. That's it. So for value of a, I will multiply this whole equation with s plus 1. For value of b, I will multiply this whole equation by s plus 2. And for a, I will put s equal to minus 1, and for b, I will put s equal to minus 2. Okay, so that's what I'm going to do now. So this will be s divided by s plus 2 if I multiply whole equation by s plus 1. Okay, this is equal to a, s plus 1 and s plus 1 will cancel out, and this will be b by s plus 2 into s plus 1. Right, and evaluate this at is equal to minus 1. When you put is equal to minus 1 here, 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 and here, okay, you will get the value of a. So when you put is equal to minus 1 over here, this will be minus 1 plus 1, 0, multiply by this thing will straight away go to 0. Okay, so you will get a here plus 0, and here this will be minus 1 and this will be 1. So a is equal to, this is minus 1 and plus 2, so this is 1. Okay, so a is equal to 1. This is one value I got. Okay, now for value of b, I will do the similar kind of thing, but I'll multiply this equation by s plus 2. Okay, so this will be, what I'll get is s plus 1 equal to a by s plus 1 into s plus 2 and plus b, because when I multiply this thing with s plus 2 and s plus 2 will cancel out. Okay, so you will get only b. Now evaluate this thing by s equal to minus 2. Okay, so when you put minus 2 over here, this will straight away go to 0. Okay, and here this will be minus 2 divided by minus 1 is equal to 0 plus b, right? So b is equal to 2. These are the values of our constant a and b. Okay, now this equation, for this equation we got value of a as minus as 1, sorry, this is minus 1. Okay, and for b this is 2. Okay, so I'll just write this down. Our original function was s by s plus 1 and s plus 2. Okay, now I got minus 1 divided by s plus 1, okay, and plus 2 divided by s plus 2. Okay, now what was my primary objective of doing this? To find out what is f of t. Now I told you that if you do little bit practice, you will understand that what is s plus 1 by s plus 1 and what is 2 by s plus 2. It means that this is the Laplace transform of some function, and this is another Laplace transform of another function. Okay, so what f of t will be? F of t will be nothing but inverse Laplace, when you take inverse Laplace of this thing. Okay, first, before, for f of s we were taking Laplace transform of f of t. Now we're taking inverse Laplace of f of s, which will give you f of t. Okay, now you reached till this step. Now look closely to 1 by s plus 1. Okay, when you find out that e raised to a power, I show you in table. Okay, in this table, when you find out Laplace transform of e raised to a power minus at, okay, that is Laplace transform of e raised to a power minus at is equal to what? 1 by s plus a. Okay, so let's play with this thing a little bit. Okay, so what will happen if a is 1, then this will be minus t, right? What will happen here? This will be 1 by s plus 1, right? Huh? If e raised to a power minus a and a is 2, then this is 2, right? This will be 1 by s plus 2. You understand something happening here. We are getting some terms for which we know that what will be the time domain function, right? So when you're taking inverse, when you're taking Laplace of e raised to a power minus at, you are getting 1 by s plus 1. When you are taking inverse Laplace of 1 by s plus 1, you are getting e raised to a power minus at. Simple, right? So inverse Laplace of this thing will be minus e raised to a power minus t. Okay, minus because here there is minus. Okay, so for constant, I told you that you multiply it in time domain and in frequency s domain, it remains the same. Okay, plus 2 e raised to a power minus 2t. This is your f of t. You understand the basic concept of inverse Laplace. Okay, you need to find out some fractions, okay, for which you know that they are Laplace transform of some function. So for inverse Laplace transform, you put just the time domain function of that particular component. So we put that particular component and this particular function. We know that one is minus e raised to a power minus t, and the second is 2 e raised to a power minus 2t. Okay, so this is a simple way. And to do this, you need to remember this thing. Okay, and to remember how you're going to remember this thing, you will need practice. You will derive delta of t, you will derive u of t as we did. Okay, e raised to a power minus at, you need to derive that yes, Laplace transform of this thing is equal to this thing. Then you will remember that inverse of this thing will be equal to this thing. Okay. So moving further, there could be different kind of transfer function. Okay, so finding the value of inverse Laplace transform is not an issue when you get components in this form. Okay, but to bring components your transfer function into these forms, okay, in summation form, you will need partial fraction. Okay, that's why we are doing partial fraction. Okay, so the one I did is that was for simple poles. Okay, I'll give you as a assignment for as a homework, actually, not particularly assignment, because for assignment I'll give you problems. Okay, so there are different kinds of transfer function. Okay, that was for simple pole. There could be a transfer function, say, of this form, s minus a whole square. Okay, how will you find out inverse Laplace of this thing? Okay, I need to find out inverse I need to find out inverse Laplace of this function. Okay, so for finding inverse Laplace, you need to find the partial fraction of this thing first. Okay, so to find partial fraction of this thing, what you need to know? You need to know the partial fraction of repeated poles. Okay, so this will be simple. Okay, this is equal to a divided by x plus a, okay, and plus b divided by x plus a whole square. You reached here. Now you need to find out values of a and b. Find the values of a and b, put it over here, and then you will see how you can find the final value. Okay, so this is I think so simple. Okay, but you will need again, I'm stressing again and again on this thing, that you need to derive these things, okay, in order to remember, okay, what's happening here. Actually, inverse Laplace of this thing is very easy. Okay, I just took a wrong example here. Okay, but we can look into many more examples. Okay, say I'll take another example. Say if you are given, I take this example from your book. Okay, so you can go and consult your book, and you will see this example there, that you are given 12 s plus 1 s plus 2 s into s plus 2 s plus 4 s plus 5. Okay, so what you need to do is to find out f of t. To find out f of t, you need to find an inverse Laplace of f of s, and to find the inverse Laplace of f of s, you need to find out the components of this thing. For that, you need partial fraction. Okay, so all the revise all partial fraction. Okay, and then you will apply over here. Okay, so I'll write it directly. This will be, this f of s is equal to a by s, b by s plus 2. This is simple. For simple poles, it's really simple. Okay, this is s plus 4 d by s plus 5. Okay, now I need to find out a, b, c, d. Okay, so first multiply this whole equation and this by with s, then secondly and then s, put s equal to 0, then second for value you will find a value of a. Okay, and then put multiply this whole equation with s plus 2, you will find the value of b by evaluating the resultant equation with s equal to minus 2. Then multiply the whole equation with s plus 4. Okay, and evaluating the same equation by s equal to minus 4. Then multiply by s plus 5 and evaluate that equation by s minus 5. Okay, you will get values of a, b and c. Okay, so I already got these values, that this is 36 by 40. Okay, and value of b is 1. Okay, value of c will be 36 over 8, and value of d will be minus 32 over 5. Okay, so I already got these values. I just need to put it over here, 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 and here. Okay, so I can write it this way, and by taking inverse Laplace of 1 by s, so you should know that this was 1 by s is Laplace transform of what? U of t. Okay, so inverse Laplace of 1 by s will be u of t. Okay, so I can say that this is u of t. Okay, plus b was how much? 1. Okay, 1, and what is what by s plus 2? This is Laplace transform of what? E raised to the power minus 2t. Okay, so inverse Laplace of 1 by s plus 2 is what? E raised to the power minus 2t. The same goes for here, for this one. Okay, this will be minus plus 36 by 8 e raised to the power minus 4t. Okay, and minus 32 by 5 e raised to the power minus 5t. See, it's really simple once you do the partial fraction. Okay, so write down few examples. Okay, that how will you find the partial fraction of such equations. Okay, so for simple pole I already show you. Okay, now for repeated poles you need to find out that if you are given such function, say x square plus 2 not x, okay, s, say s square plus 2s plus 5 over s minus say 5 square into s minus say 3. Okay, you are given this function, and you need to find out inverse Laplace of this f of s. Okay, find inverse Laplace of f of s. So it means this will be equal to f of t. So you need to find out f of t. Okay, so solve this. Okay, use partial fraction. Okay, find different components, and then use this table. Okay, when you do partial fraction, you will get some components from here, either this one, this one, this one, this one, this one, and so on. Okay, and then use inverse Laplace, and you will find out time domain function f of t. Okay. The other one, sometimes you might get a function like this. Okay, say s square plus 7s plus 3 divided by s minus 7 into s square, say plus 7 s plus 3. Okay, say this is your f of s. So I will say this is f1 of s, this is f2 of s. Okay, and my question is find f of t. Okay, so to find f of t, finding f of t is not a big deal. Solving this partial fraction is a little bit tricky. Okay, so just go back, revise the partial fraction concept. Okay, divide it into different components, and you will get how to solve this partial fraction. And when you get those components, you will see, definitely see that it will belong to one class, either from here or here or here or here or here, and so on. Okay, so this is it for week 13 and chapter number 13 as well. So if there are any questions, feel free to contact me. You can always ask questions using your WhatsApp group, but I'll recommend that you place your queries on MS Teams, because everybody have access to MS Teams, and everybody will see. Maybe 5 or 10 students might have the same questions or the same queries. So feel free to ask questions and go through these lectures if you don't understand anything. As I told you, you can always welcome to ask. Okay, so this is the end of chapter number 13. You will get an assignment hopefully on Friday. So do go through these lectures before I assigned you the assignment. Okay, thank you.